All right, question 7. Drag the tiles to the correct boxes to complete the pairs. Not all tiles will be used. Consider the graph of the function f of x equals log x. Remember, that has an assumed base of 10. They've not written in there. So that's log base 10x. And this is the picture. So this is the picture we're going to base all of our answers on in this example. The question below here says match each transformation of function f with a feature of the transformed function. Okay, so that's kind of a mouthful there. Let's scroll down a little further so we can see the actual questions here. Yeah, so we've got the original function here. This is what we'll call this our before picture. And these three are going to be the after picture. We got to figure out, well, that 1/5, that plus 5, and that minus 5, what are they doing to that before picture? So that's the task in this problem. And up here to the top right in blue, I've written the transformation rules. This should be kind of old hat at this point. You've seen this before, these transformation rules. The A value specifically is a vertical stretch, shrink, and reflect. That's going to be important in this problem. The H value shifts us left to right. That's kind of the tricky one. If H shows positive, we shift left. If H shows to be a negative, we shift right. And then K shifts us up or down. Okay, so then let's go through each question. Let's start with H. Function H shows 1/5 times f of x. So this is an A value. That's positive. That's between 0 and 1. So this is a shrink. And specifically, it's a vertical shrink. Which coordinate is our vertical coordinate? It's our y coordinate. So it's our y coordinate that's being affected here. So everywhere you see this graph, it should, imagine you squeezing it. Imagine you applying pressure to the bottom and top of this. What would that do graph look like? Well, it would be really short. It's going to look something more, let me do this in black. It's going to look something more like this. That's why this one's kind of tough to do in the calculator. It almost looks like a straight line, but it's not. It's just a curve that's been squeezed lower. The y coordinate has been multiplied by a factor of 1/5. Now, I know the answer is this. So how do we know that? The x-intercept of 1, 0. Well, other than the fact that I drew it to go through 1, 0. Well, remember, the y coordinate is the one that's being multiplied by 1/5. Only the y coordinate, not the x. Well, what is the y coordinate here at the x-intercept? It's 0. So if you take 0 and you multiply it by 1/5, what do you get? You still get 0. So we know that can't be it. And then if we went through the other answer choices, we can pretty clearly see the other answer choices don't work here either. Domain from 5 to infinity, that means the domain is talking about the x's and how far we're moving left and right. Well, if the domain goes from 5 to infinity, that means we just be looking at this point and everything to the right. Like this graph here has a domain of 5 to infinity, but the blue graph, the original, clearly moves to the left of that. So that doesn't work. The range, this is talking about the y values, how far up and down it goes. This is saying the lowest y value is 5. Well, that's clearly not accurate. We can't even see 5 on this graph. So that's not going to work either. Okay, so this one is, we go back to our original premise. This one is, the answer is the x-intercept of 1, 0. All right, next function is the g function. This says negative f of x plus 5. So it has a negative a value, which means this is a reflection. And then that plus 5 That's our K value, means we're also going to be going up 5. So this is a reflection over the x-axis. And then we're also going to go up 5 when we graph this. So imagine what that reflection would look like if you took every point from this original graph and reflected it to the other side of the x-axis. So see how this point is a half above the x-axis? Its mirror image would be a half below. This point is 1 unit above the x-axis. Its reflection would be 1 below. Let's go further out. This point here is about 1.5 above the x-axis. Its reflection would be 1.5 below. This point down here is about 1.5 below the x-axis, so its reflection would be 1.5 above the x-axis. And at this point, we can kind of see what that graph would look like. That's the reflection, but then the next thing we've got to do is we've got to take that entire graph and shift it up 5. Now that's a little tricky here because we really don't have a graph that goes very high. We're pretty much at the highest point, so let's just visually think to ourselves, okay, this graph, what would it look like 5 units higher, and answer these questions. It's not going to affect the domain. The domain is, again, the x values. It's how far left and right the graph goes. So a shift of up 5 doesn't affect this answer. So we can use, I'm going to go and connect these dots just so we can get a visual. The domain of this graph is not 5 to infinity. That would imply that our graph starts here at x equals 5 and moves to the right forever. And that's just not the case with this problem. The one that's tricky is this next one, range of 5 to infinity. Oh, you think, well, we are going up 5, but the problem is, two problems here. One, the lower number is not going to be 5, but that part could be up for interpretation. I could see how that mistake could be made. The real issue is it's saying this, the range, the highest range value goes up to infinity. So that implies this graph is going up forever, and we can clearly see we've got a downward pressure on this graph. It's going down as we move to the right. So the range from 5 to infinity, that can't be it either. And then finally, decreases as x increases. So as x increases, that means the graph is moving to the right. So as we're moving to the right, is this graph decreasing? Well, absolutely it is. As we move to the right, we're decreasing, so that's our answer. Decreases as x increases. All right, and then finally, it's a long problem, J. J shows f of x minus 5. So that's going to be the h value. Mine, it shows a negative, so that means we're going right 5 in this problem. So right 5. So we've got to take each one of the original points and just shift them roughly right 5 units. Start here. This one's easy enough. So from 1, 0 all the way to 6, 0. If we increase this one by 5, that'd be 1, 2, 3, 4, 5. Be right about there. And obviously the rest of these are kind of tricky because they're going to go way off the graph. 1, 2, 3, 4, 5. So it'll be somewhere right around here. So our graph looks something like this. It's really just the original graph, just everything shifted to the right 5. So we know it's not this one. It's already been used. This one's already been used. So it's either the range or the domain. Well, I'm going to focus on the domain because domain goes left and right, and we just shifted this thing to the right. When I just realized I actually made a mistake. Right here. This point, I didn't shift it right 5 units. Because remember, it's counting by 1 every 2 blocks here. So if I shift it right, there's 1, there's 2, there's 3, there's 4, there's 5. And then this point should actually be a little bit further to the right. So yeah, those counting by 2s messed me up. So there's the graph. That's important because that's going to affect our domain. We can clearly see domain of 5 to infinity is what we've got going on here, because this point is kind of where the graph starts, and it's starting just above 5. Not at exactly 5, but just at above 5. If it was starting at exactly 5, we would say the domain is bracket 5, comma, parentheses. But since it's starting just above 5, it means it's getting closer and closer to 5 without actually touching it. 5 is the asymptote. So the final answer here is the domain goes from 5 to infinity.